this video, we'll talk about how to determine the equation of a quadratic relation that either matches a specific graph, where you can pick out key points from the graph, or how to determine an equation of a quadratic relation given specific information about what the graph looks like. So, first example, it says determine the equation of the quadratic relation that has x-intercepts of -3, 0, and 1, 0, and the quadratic relation goes through the point 0, 6. Now, in this case, this point 0, 6 happens to be a y-intercept, but it doesn't have to be a y-intercept in order to use this process that we're going to do right now. It could be any other point on the parabola. So the first thing we notice is that the information we're given is mostly about the x-intercepts. And we have three different forms of the quadratic equation, or three different forms that we can use to represent a quadratic graph. The first is using standard form. So that's y equals ax squared plus bx plus c. The second is using factored form. So y equals a times x minus r times x minus s, where r and s are the x-intercept values. And the third way is using vertex form, which is what we use for transformations. So that's y equals a times x minus h squared plus k, where h comma k gives the vertex of the parabola. So because this particular question deals with x-intercepts, we're going to use the form of the equation that shows what the x-intercepts are directly from the equation. So we're going to start with y equals a times x minus r times x minus s, and start by substituting in the x-intercept values. So the first x-intercept is -3. So I'm going to substitute that in for r. So I'm going to have x minus -3. And then the second bracket will substitute in the other x-intercept, which is 1. So we have x minus 1. Okay, so that's the first step where we substitute in the x-intercept values. The other information that we have is that this parabola goes through the point 0, 6. Well, 0, 6 gives us an x and a y coordinate that we know will satisfy this equation because it's a point on the graph. So if we can substitute in that point for x and y in our equation, the only variable that's left unknown is a, and that's the only piece of information that we need to write out the equation of this parabola. We already have the x-intercept, so the only other piece we need to fill in is a. So let's substitute in the point 0, 6 for x and y. So y is the value of 6. Equals a times x minus -3, can also be written as x. Sorry, hold on. Let's back up a minute. We're going to substitute in x value as well. So the x value is 0 from this point, 0, 6. But this x minus -3, we can write that as x plus 3, so 0 plus 3. Then here we have another x, so we have to substitute in that 0 there as well. So 0 minus 1 for that second bracket. So now if we simplify and rearrange, we should be able to solve for what the a value is in this equation. So we get 6 equals a times 3 times -1. So 6 is equal to a times -3. Dividing both sides by -3, we get a is equal to 6 divided by -3, which is -2. So now, going back to the beginning of the question, we have to write the equation. So not just determine the a value, but write the equation. So we say, therefore, the equation of this parabola is y equals, we're going to fill in the value of a, -2. And we started with factored form, so we're going to write out the factored form here. X minus -3, so x plus 3, and x minus 1. So we filled in everything except for the x and y variables. This is the equation of our parabola. Y equals -2 times x plus 3 times x minus 1. Okay, we're going to do another example that's similar but a little bit different. Here we are determining the equation of the quadratic relation that has a vertex of 4, comma 1 and goes through the point 8, comma 5. So here, because we're given the vertex, we're going to start with vertex form. So y equals a times x minus h squared plus k. Because we know that h and k are the coordinates of the vertex, we can substitute in 4 and 1 in place of h and k. So when we do that, we get this equation. So x minus 4 in the bracket squared plus k, which is 1. Okay. Now, the other piece of information we have is that the parabola goes through the point 8, comma 5. So that gives us an x and a y value that we know will satisfy this equation because it is a point on the graph. So we can substitute in 8 in place of x and 5 in place of y, and that will allow us to solve for a. So then we have the equation 5 is the y value. The x value is 8 minus 4 squared plus 1. Now solving for a, we would first subtract 1 from both sides. So we get 4 equals a times 8 minus 4 is also 4, so 4 squared. 4 squared is 16. And dividing both sides by 16, that gives us 4 over 16 is a, or a is equal to 1 over 4, so 1/4. So that tells us that the equation of this parabola in vertex form is y equals a, which is 1/4, times x minus 4 squared plus 1, because the vertex was 4, comma 1. So depending on what information you're given in this type of question, you could start by using vertex form, or you could start by using factored form, depending if you're given the vertex or the x-intercept. And then you are substituting that information in, followed by substituting in one additional point that's on your parabola. And this process will then allow you to determine the equation of any parabola as long as you have either the vertex and a point, or the x-intercepts and another point, or if you have a graph of the parabola where you can pick out that information.